Welcome to Lesson C-11. In this lesson, you'll learn about different components required for establishing communication over a network. You'll also learn how to use a Python package named Bottle to create and host a web page on your Raspberry Pi. This web page will later be used to control the color of your RGB LED from another device on your network. In this video, you'll learn more about how to access your Raspberry Pi projects remotely. Specifically, we'll be looking at web page control and the HTML code you'll need to know. And then in the next video, you'll learn how to use the Bottle software to set up a web server, as well as how to work with the PIP installer. Okay, before we jump in, we need to talk about the idea of a web server. While I'll be using the term web server throughout this lesson, the server you create during this lesson will not be available outside of your home network. Making this server available outside that home network by modifying your home router or firewall settings would be far outside the scope of this lesson. Making any server on your home network available to the internet is a major security risk, and you should not attempt to do that unless you have extensive network security knowledge. Okay, unless you work in the network security field, this is not something you should even think about doing. The ability to control a project with a web page interface can make a project much more useful. Instead of controlling a program or hardware with a keyboard or mouse connected directly to the Pi, you can make the program control available to any device on your home network that can launch a web browser. These types of devices might include phones, tablets, smart TVs, gaming consoles, or any other device with a web browser. The complexity of your web page might cause issues on certain devices, though. So for example, a web page that can be properly displayed on a computer might not display or function well on a phone due to the software support in the browser of the phone. So keeping web page control simple is the best way to ensure the highest level of compatibility across all devices. The components required for web page control of a device are a server and a client. The server refers to the hardware that is serving or hosting the web page. This hardware could be something as small as like a Raspberry Pi, or it could be a much larger device like a full rack of powerful computers. So the server hardware required will depend on the amount of information that you want to make available. A large website like Google or Facebook requires entire buildings, multiple huge buildings called data centers that are full of thousands of extremely fast servers that are all working together to serve the website to everyone. Luckily, you only need the Raspberry Pi for hosting a couple of simple web pages like we're going to do. Now, a client refers to a device that connects to a server. The client might be a PC, a tablet, a phone, or any other device that can load a web page. Depending on how it's used, a Raspberry Pi can be a server, a client, or both at the same time. When hosting a web page, it's considered a server. When accessing a web page using its web browser, then it would be considered a client. And since both of these things can happen at the same time, the Pi can be a server and a client simultaneously. During the lesson on remotely accessing your Pi, you learned how devices are identified on a network with a unique IP address. When a device is running a server, the content being hosted by the server can be accessed by other devices on the network by using the server's IP address. A device can host multiple servers at the same time, and then the port numbers are used to identify them. So port numbers specify which server you want to communicate with at a certain IP address. Port numbers will be between 0 and 65,536, so there's lots of options, and will follow the IP address separated by a colon like you see here. The VNC and SSH protocols that we use to access your Pi were running as servers on the Pi, and here are some of the most popular ports. These port numbers are the default port for each protocol listed. This means that you don't always have to specify a port when accessing these services. If you're trying to make a VNC connection to a VNC server running on 10.0.0.83, the VNC client software will automatically attempt to communicate using port 5900. If the server is up and responds to a request on port 5900, then a connection will be established with that server. Web browsers will automatically attempt to communicate with a server on ports 80 and 443. And if a connection is established on one of those ports, the website content will be loaded in the web browser. These default ports can easily be overridden by a client by supplying a different port number, when connecting to the server. So if the server at 10.0.0.100 has been configured to run SSH on port 6022, then you can connect to SSH by pointing your SSH client to 10.0.0.100:6022, just like you see here on the slide. It's a nice long number. Not all users, though, can access all ports. For instance, processes created by Thonny will run as the user named Pi. Remember Pi? Which has limited permissions, right? The username Pi is not allowed to access certain ports like 80 and 443 because of security concerns. Now, the options in this case are to run the process as the root user, which has other serious security considerations, or to select a different port to use for the server. Now, since there are around 65,000 ports to choose from, it's not too difficult to find an unassigned port in the upper area of this range. So port 8080 is a pretty common alternate port to use for web servers. Now, one more quick note before we move on. There can only be one server type assigned to a port number. This means that if you're running a web server on port 80, you cannot also assign an SSH server on port 80. Attempting to assign multiple services to the same port will result in errors. All right, let's switch gears and talk about HTML for a bit. Since you're working through this course, I'm going to assume you are interested in computer languages, and of course HTML is one of the most common. But since everyone is going to have a little bit of a different background coming into this course, I'm going to take a few minutes to quickly review the basics. So this may be just an old hat to you, or it may be brand new, but we're just going to go through the basics so everyone's on the same page. HTML, or hypertext markup language, is used for creating web pages. Just like Python, HTML code can be as simple or as complicated as you would like. So here's an example of a simple HTML file. This file will display the message "Hello World" in a web browser. The doc type code tells web browsers, lets web browsers know that the code in the file is HTML, so it can be properly displayed in the web browser. HTML relies mostly on items called tags that look like this. Both tags are enclosed with angle brackets, while the closing tag also includes a /. These tags are wrapped around some type of content. Let's take a few minutes and walk through the more common tags you'll find in HTML files. Understanding these will really help you look at HTML code and just understand what it means. The HTML tag you see at the top encloses all HTML code on the web page so it can be properly interpreted. The head tag is used to mark the heading of a page, and it should come before the body content. The body tag contains the main content of the web page. Now, H1 through H6 are predefined heading styles. So H1 is the largest, H6 is the smallest, and they can serve other functions too. For example, historically, search engines placed emphasis on your H1 and H2 tagged content on a web page when it was deciding what a page is about and how to rank it in a search. And they use them because H1 and H2 are basically large fonts in your website. And so they tend to be used for your main headings and your subheadings on your web page. So it made sense to say, well, this must be what the page is about then. Now, the paragraph tag holds items together in paragraphs, and then the break tag inserts a carriage return so the layout of your page can be more user-friendly. Okay, now I'm going to move on to another type of tag on the next screen, but this is a lot of info. So if this is new to you, feel free to pause this video here and take a closer look at these descriptions if that would be helpful to you. All right, let's talk about the hyperlink tag. This tag is used to create a link to another page or file. And unlike the tags we just looked at, the hyperlink tag requires more than just an opening and closing tag. So this tag also needs the text or the image that will be used to display the link on the page, as well as the target location of the link. So it's just a little bit more complicated to set up. Okay, so in this code box you see here as an example of creating a link with the text "Visit 42 Electronics." So that's the text that would appear on the website. But if you click on that text, it goes to the link, which is the website address there for our website. The target link location is included in the opening, or that A tag, followed by the text that will be displayed, and then the closing A tag. So all of these tags we've just reviewed are nested inside each other to form the content of the page like you see here. This is a very, very simple HTML web page. All right, so let's put some lines, I'm gonna put some boxes, okay, around these different sections here so we can better see the tags we've been talking about. Oh boy, okay. So you can see that the HTML element holds both the head and body elements, and the H1 heading is located inside the head element, and the paragraph element is located inside the body. Okay, so keeping opening and closing tags spaced at the same level does help keep this organized. All right, now let's look at the code box. Now this code box is the exact same code box as above. Sorry, I gotta click that. Okay, this code box is the exact same code box as above, but the spaces have been removed. Okay, so if you were to go look at the text on any web page on the internet, it's gonna look all squished together for the most part like you see in this bottom box. It's not gonna necessarily be as clean as the top box. The web page built by these two files will look identical in a web browser, but the file with proper spacing will be much easier to be modified later, especially when you're learning, right? Because as opening and closing tag locations are nice and organized, it makes it much easier to identify what you're doing. A missing or opening or closing tag will break an HTML file. Believe me, I have done this. It's not fun. And this type of problem is much easier to fix when the code is formatted like the first example versus the second, where you're really digging through tags trying to figure out what's missing. Okay, before you move on to the next video, let's take a few moments and go over the concepts we just discussed. In the activities, you'll be working on setting up a web server to host a web page to control your projects remotely. And there are two components required for web page control. The server, which is the hardware that hosts the web page, and the client, which is the device that connects to the server. The Raspberry Pi can actually function as both the server and the client. So a device can host multiple servers at the same time. The device will have an IP address, and then the server's port address will be listed after the IP address and a colon. And then we looked at HTML code, which is used to build web pages. HTML relies mostly on tags, which are wrapped around content and nested together to form the content of the web page. Now, go ahead and move on to the next video where you'll learn how to build a simple web server using a software called Bottle.